Hello students, I am a Dr. S.M. Bhatti. The objective of this video is to introduce Fourier Transform. Let's see first the basic definition of Fourier Transform. Let f of x be defined by the interval minus infinity to plus infinity. That is minus infinity less than x less than infinity. Fourier transform of the function f of x is denoted by capital F of lambda and defined by this integral. Integration is from minus infinity to plus infinity f of u e raised to minus I lambda u d. Here f of x is the given function. From f of x one can find f of u by replacing x by u. I is a imaginary unit which has a value under root of minus 1. Here u is a variable of integration whose limits are from minus infinity to plus infinity. You can see this real line. This real line has a limit minus infinity to plus infinity, and in between these two there are infinite many numbers. All these are the real numbers from minus infinity to minus 3, minus 2, minus 1, 0, 1, 2, 3, 4 and so on. Here I have written only integers including positive integer, negative integer and 0. But this real line also contains fractions, rational numbers, irrational numbers, right? Now because here u is a variable of integration, so when you carry out actual integration in right hand side from the limits minus infinity to plus infinity, you will find that for the right hand side will be a function of only lambda. Note that here u is a variable of integration and lambda is constant for integration purpose. You can see that this Fourier transform transforms function of x to function of lambda. F of x is a function of x and capital F lambda is function of lambda. And Fourier transform function of x to function of lambda. Now in this case the function f of x is called inverse Fourier cosine transform of capital F lambda, and this function f of x is given by this formula. You can see in left hand side there is f of x. In right hand side we have constant 1 upon 2 pi integration from minus infinity to plus infinity capital F lambda e raised to I lambda x d lambda. Here we have d lambda. That means for this integral lambda is a variable of integration and limit lambda has a limit minus infinity to plus infinity. And another thing is here we have x constant. So when you carry out actual integration in the right hand side with respect to lambda from the limit minus infinity to plus infinity, you will find right hand side is a function of x alone, and this can be justified from the left side which contains a function f of x, that is a function of x alone. You can see that this equation 1a give you value of capital F lambda, that is a Fourier transform of the function small f of x, and equation 1b will give you value of function f of x in terms of certain integral. Definitely if the function f of x is given, then its Fourier transform, that is capital F lambda, can be obtained from this equation 1a. Conversely, if we know the value of capital F lambda, then using this equation by taking the value of capital F lambda in right hand side and making simplification in right hand side, that is integration with respect to lambda, we can obtain the value of f of x. That means if capital F lambda is required, we can use this equation. If capital F lambda is given, if small f of x is required, we can use equation 1b. Let's see second important definition, Fourier cosine transform. If f of x is defined in the interval 0 less than x less than infinity, then Fourier cosine transform of function f of x is capital Fc lambda and defined as integral from 0 to infinity f of u cos lambda u du. You can see that here du, so u is a variable of integration and limit of u are 0 to infinity. And f of u can be obtained from the f of x by replacing x by u. For this integration purpose, we have to keep lambda constant. So when we integrate this integral with respect to u, keeping lambda as a constant from the limit 0 to infinity, you will find the right hand side will be only function of lambda, and it can be justified from the left hand side, which is a symbolically function of lambda. Now in this way, f of x is the given function and its Fourier cosine transform is capital Fc lambda. Conversely, if we know the capital Fc lambda, we can get the function f of x. In fact, if capital Fc lambda is Fourier cosine transform of f of x, then f of x is called inverse Fourier cosine transform of Fc lambda. That means we can say that in this case the inverse Fourier cosine transform of Fc lambda is f of x, and it is given by the equation f of x is equal to 2 upon pi integration from 0 to infinity Fc lambda cos lambda x d lambda. Here is d lambda means lambda is a variable of integration, so x will be constant here, and you can see that here limit of lambda is 0 to infinity, and when you carry out actual integration you will get a function of x alone, and this can be justified from the left hand side where we have a function of x alone. In short, if the function f of x is given, then Fourier cosine transform is given by the equation Fc lambda, and if Fc lambda is known, then we can use this equation to find the value of small f of x. Now we can define third important definition, Fourier sine transform. It is just like a Fourier cosine transform. By replacing cos by sine, you can get equation 2a and 3b. 3a and 3b. Let's see in detail. If a function f of x is defined in the interval 0 to infinity, that is x is a positive number but greater than 0 and less than infinity, then Fourier sine transform of function f of x is capital Fc lambda, and it is defined by this equation capital Fs lambda is equal to integration from 0 to infinity f of u sine lambda u du. In this case, inverse Fourier sine transform of Fs lambda is f of x, and it is given by the equation f of x is equal to 2 upon pi integration 0 to infinity capital Fs lambda sine lambda x d lambda. We call this equation as 3a and this equation as a 3b. Up to now we have seen three important definitions: Fourier transform, Fourier cosine transform, Fourier sine transform, and their inverse transforms. Now we can summarize all these three definitions, that means three pairs or six definitions in the tabular form. So this is the table of Fourier transform and their inverse transform. Here the second column represents type of a transform, Fourier transform, Fourier cosine transform, and Fourier sine transform. Now for this Fourier transform, the function has a range minus infinity to plus infinity, means all real numbers, while for remaining two transform we have a range 0 to infinity, that is here x is a positive real number. Here in first case x is any real number, while in 2 and 3 x is a positive real number. So Fourier transform is capital F lambda and its inverse transform is small f of x. Fourier cosine transform of f of x is epsilon lambda, its inverse transform f of x is given by this equation. Now the Fourier sine transform of the f of x is fs lambda given by this equation, and its inverse transform, that is inverse Fourier sine transform, is given by this equation. You can observe that here we have a constant 1 upon 2 pi, while for the remaining two we have a constant 2 upon pi. Here for all the three equations u is a variable of integration, while for the inverse transforms we have a lambda is a variable of integration. Here for the integration we have to keep lambda constant, while for these type of integration we have to keep u as a constant, x as a constant. Fine. These are the important definitions, and now we are going to make use of this equation as per our requirement. Let's see an example. Find Fourier transform of function f of x equal to e raised to minus mod x. Here is a f of x as e raised to minus mod x. Now Fourier transform of function f of x is capital F lambda, and it is given by equation 1a, that is capital F lambda is equal to integration from minus infinity to plus infinity f of u e raised to minus I lambda u du. Now we put the value of f of u became e raised to minus mod of u, and in next step we can put the value of e raised to minus I lambda u. We know this formula. This e raised to minus ix is a cos x minus I sin x. Using this formula we can write down this quantity as this, then multiply this bracket by e raised to minus mod u and split the integral in two terms. We have this. Here we observe that the first term the integrand is a even function, while in second term the integrand is the odd function. So we have to make use of properties of integral. Since the integrand in the first integral is even and second integral is a odd, so we have to make use of the following property. So property is here integration from minus L to plus L fx dx is a 2 times integration from 0 to L fx dx if fx is even function, and second property is integration from minus L to plus L fx dx is equal to 0 if fx is odd function. So using these two property, the first term became 2 times integration from 0 to infinity e raised to minus u cos lambda u du, and second term became 0. Now here is a 2 times e raised to minus u 1 plus. Now we have to make use of standard formula. So using the formula e raised to minus u upon 1 plus lambda square in the bracket minus cos lambda u plus lambda sin lambda u with limit of u as a u is 0 to infinity, and in next step we can get the answer that is a 2 upon 1 plus lambda square. Here we are using the standard limits. Note that here is integration of e raised to minus u. That is not actually printed in good way. It is not looking in that way. I hope that you are understanding this. We have used two references. The first is from Dr. B.S. Gravel, Higher Engineering Mathematics, Khanna Publisher, New Delhi, 2014. Another is S.R. Safre, B.S. Wage, myself S.M. Bhatti, Navin Mani, Engineering Mathematics 3, Gigatech Publishing House, 2018. In this way, today we have seen definitions of Fourier transform.